In class today, we made this little tinker, okay, some LEDs, and we made them all turn on, all turn off, and then we made them sweep right with a certain number of milliseconds in between each on and off, and then we made it sweep right off. Okay, so this is where we stopped in class. All right, so what I want you to do now is do this, create this little guy. Okay, so I'll run it with the code we just had. So all on, all off, sweeps to the right, sweeps to the left, and now we want it to sweep to the left. Okay, on and off. So let's watch it again. All on, all off, sweeps to the right on, sweeps to the right off, and then sweeps to the left on, and then sweep to the left off. So let's see what that looks like if I just get rid of it and only do the left. Okay, so now we're counting backwards. We're starting here and going this way. So we start with 11 and go down to 2. Okay. All right, so that's one thing I want you to play with. And I will, at the end of this, I'll show you pages from the textbook that will help you. So I'm going to stop the simulation. And now I am, so you can keep it all in your sketch together, but I'm going to delete it. And I'm going to add this little guy. Let's see here. Okay. So then I created 4 more functions called evens on and odds off, and evens off and odds on. So this will turn on the even numbers, 2, 4, 6, 8, so on, and it will turn off the odd numbers. And when I say odd numbers, I actually mean pin numbers, odd pin numbers. So really, it's kind of funny, but pin 2 is actually LED number 1. So when I say odds on, I mean pin numbers on, to make it simple. Okay. So they're on, and then all of the evens pins are on, and then all of the odds are off, and then all of the evens are off, and all of the odds are on. So we can make this be a little bit longer if we want to. So all of the evens are on, and then flops over. So in order to turn on the evens, you really should turn off the odds, and vice versa. Okay. And so that means that, let's see if I can't find the code. So there's our sweep left. And if I put it back in, let's see if I can't find that original. Yeah, that looks like it's it. Okay, so this is now the whole piece of code with all on, all off, sweep right on, sweep right off, sweep left on, sweep left. I put this delay there so you can see it more easily. Evens on, evens off. And then it will do it all over again. So see if you can't get this stuff done. All right, so let's take a look at the textbook. This is chapter 11. Okay, page 308 in the textbook. I don't know what it is on the online version. It's going to be probably like 350, something like that, 340, 350 in the textbook. On the electronic textbook. So this is, I just wanted to show you the shorthand notation X++. Okay, so this is what the long notation looks like. We also have shorthand for X minus minus. It subtracts 1. Okay, maybe that will help you in this. And then we also have X plus equals 2. All right, if we wanted to, for example, increase the counter by 2 every time or decrease the counter, this is how you could add 2 to the loop. Okay. So there are some examples, lots of good examples in here, if I do say so myself. This is the basic example, just printing hello, showing people how to use the loop. Slowing things down with the delay, and then odd. So here we are counting by we started at 1, we go up to 9, and 1, 3, 5, 7, 9. So this is how you might count by odd numbers. Okay. Let's see, what's the next example? Example 5 is counting up and down by 5s. Here you're counting up by 5 and counting down by 10s, rather. Up by 5 and then down by 10s. Okay. So you start at 0 and you go to -40, and this is how you would make it go down. Geometric, we don't need to worry about that. Why don't we have counting backwards? Let's see here. I guess this is counting backwards. If you wanted to start at 40 and count down to 0, you would make this be a 40. Notice that this this less than sign here is important when you're counting up, and when you count down, going down, notice that that sign swaps. That's an important piece. So this adds 5 and this subtracts 10 from the counter. We have two different counters here, I and J. You could have repeated I and I, both times, but this separates it out a little bit with variables. Okay, hopefully that helps you. Good luck. Thanks. Have a good day.